Go.
Hey, Dr. Zhang. For my last project, I'm going to be doing conservation of mass, and we're going to see how long this water bottle takes to empty. And I have here my uncle helping me out. All right, let's get it going. All right, where am I going to do it? 3, 2, 1. Okay, stop. All right, well, it's all right. It's about 3-ish seconds, okay? And we're gonna move to the math to prove that. Thank you very much, Uncle Robert.
Thank you,
You're very welcome.
All right. Okay, wow. So that water came out speedy quick and way faster than I expected, but our math should prove that time. And after reviewing the footage, I found that our actual time on the stopwatch was 3.34 seconds whenever all the water emptied out. All right, so let's go ahead and start off with the dimensions of our bottle. Our D1 is going to be the open top end, and our D2 is going to be the bottom end. And for each of those, we have 3.5 inches and 7/8 inches. And then our height of the water, which was not all the way full to the top, it was full to a line that I could easily measure, and that is going to be 8.75 inches. Now, of course, I've converted these into meters just to make our calculations a little bit easier. But let's get started. So we're going to use the conservation of mass equation, which is conservation mass plus flow rate in minus flow rate out equal to 0. Well, we don't have a flow rate in, therefore it's just a flow rate out, and we can go ahead and cancel our whole flow rate in for the equation. That leaves us with conservation mass is equal to the opposite of the flow rate out. Well, we can go ahead and start substituting in variables. Our conservation mass is going to be the derivative of times the area times the height times density. And our flow rate out is going to be opposite of density times volume times area. Now, since we're using water, and water is the only thing in this equation, our density is going to be, canceled out in the equation. And our friend Bernoulli over here is going to help us out, because whenever you have a situation like this where pressure is just an atmosphere and it's just liquid falling out, we see that Z is actually equal to V squared over 2G. So when we solve down, V is equal to the square root of 2GH. Alright, so now once we simplify a bit, we get down to this equation here, which is going to be the derivative of our height equal to the negative square root of 2G times area of our bottom divided by the area of our top times time. And what we want to do here is solve down for time, since we have all our variables besides t. So once we plug in everything we know, we have a time of 3.37 seconds. And this makes me very happy, because I thought we would be a little farther off, but we are absolutely almost spot on with our time of 3.34 seconds. So that goes ahead and verifies our conservation of mass equation, and we can call it good to go. And I just want to say thank you very much, Dr. Zhang. I had a very great experience this semester, and I hope to see you again.